Okay. As you can see, thank you for being there. So we are going to start this session. As you can see, we are working with hardware, so we need the hardware to be set up before we can start this. And since everything is in this computer, I'm not sure we're going to have the slides. Anyway, I'm going to start this while we finish setting up. That should be good.
Yeah, we can launch on the robot. On peut commencer avec le robot.
Pour qui veut la présentation? Tu veux lancer la présentation depuis le robot?
Juste le début.
Ok, vas-y si tu veux. So we're going to launch the presentation with the robot.
Everybody, I am now, and I am Pepper. We are Aldebaran's robot. Hello, Pepper. It's so nice in here. Hello now. Yes, I'm having so much fun with Java. I didn't expect that much people. Do you think you can handle it? Well, you know, my 3D sensor only reaches so far as the first or second row. Blank room for me. No real pressure.
Okay, that's to give you an idea of the kind of dialogue that we can build with the robots. Jean-Philippe is going to give you more insights on that later on this talk. I'm going to start it. So my name is Nicolas Rigaud. Maybe you were attending the quickie I gave 2 hours ago. We are both working for Aldebaran. Aldebaran is a French company, and we are building robots, no surprise. The first robot we built was Nao, which is kind of pretty famous even in Devoxx. I think it's the third year that we are showcasing it. And for the first time in Europe at a developer conference, you can also see Pepper, that was on stage this morning for the keynote, and we're going to give you an overview on the programming side for our robots. But I just want to give a few words about the reason why we do that and what we do. So as you can see, there's Nao that you know, there's Pepper, and we also have a third one, which is called Romeo, and Romeo is more a research project. Anyway, the common point in all the robots that we are building is that they have this human body form factor that is definitely making sense for us. We build robots that are dedicated to interact with humans. We don't focus as a company on performance. Our robots are not going to carry heavy load for you and cover long distances and stuff like that. That's not the purpose for us. For us, what we want to do is robots that people want to engage with and interact with. And that's really, from our point of view, where the value lies with the robots that we are making. Of course, there are also programmable robots. So the idea is that we deliver as a company a platform that as developers you can take advantage of and fine-tune this platform so that it can be used in some industries or for special use cases. Nao has been widely used for education mainly. Pepper is a robot that is, due to his size, you don't have to choose between interaction or autonomous behavior for the robot, for Nao, or you have it on a table and you can interact with it, or it's on the ground. It can be mobile, but it's harder for you to interact with it. With Pepper, we really have the size that allows you to take advantage of mobility and of interaction at the same time. Nao has been mainly used in education, but Pepper, at the moment, is mainly used in B2B context, and more specifically for retail. It's a robot that is already in use in shops in Japan, facing customers and interacting with them. So we can discuss later on during the Q&A session the use cases if you're interested in this part. But I guess that the part that is the most interesting to you at the moment is the technical side and how we program our robots. As I was saying, so Nao has been available. At the moment, Pepper is only a robot that is available for Japan, but we start investigating the European market, so I expect in the 12 months to come to be able to buy this robot and use it, program it for yourself, or use it for your company. Jean-Philippe is going to give you more details about the hardware, the kind of sensors that we have on the robot, and how to program them, but that was just to give you a brief introduction. We are at Aldebaran, we are building robots that are dedicated to interacting with humans.
Thank you. So, a few more details on Pepper and Nao, the little guy. So Pepper is 1 meter and 20 centimeters high. It's really the first humanoid robot designed to live with humans in the way that customers in Japan are already buying Peppers and living with Peppers at home. You have wide range of functionalities, but we will talk about that more later on the technical side. Move, recognize people, talk, and everything. Now, basically, okay, LibreOffice crashed. That's funny. Sorry for the little delay. I will talk in the same time that I'm trying to debug that. No. So now it's the firstborn, let's say that, in Aldebaran. The first real version of Now dates back from 2006. And we've been mostly using it in academic, as Nicolas said. So, on the technical side, we provide access to the functionalities of the robot through Naoki, something that we call Naoki. It's the main software that that runs on the robot, and in terms of structures, everything is handled by a session that will give you access to modules which has functions. How to use it? Sorry for that. The native language for using Now is Python, but you can use it in other languages thanks to a middleware that we call libkey, and which adds a layer, an additional layer, which is an application that will handle sessions and which will initialize basically the Naoki framework. So you have APIs, of course, in Python, C++, JavaScript, and of course, Java. If not, we wouldn't be there today. So you have a Java SDK, which is available, so it's now available for everyone. If you want to try what we are going to show you today at home, you can. It uses the C++ API, and it allows you to create your own services, your own applications that can run either on your computer or on the robot. If you want to use it on a robot, you will have to install the Java runtime environment, as it's not installed by default on the robot, but it's doable. So, let's talk about code. So that's the code that we used just earlier for the introduction, but we'll start from 0. And it would be easier to have a screen a little bit closer. Let's start from scratch. Hello, Devoxx. So it's a bit ugly, but we don't mind. Hello, world. We'll need the SDK, adding that. And we're good to go. So, as I said, the first thing we want to do is to create an application, okay, which will allow us to access the session, then the modules, and the functions from the modules. Application. And to initialize the application, of course, you want to connect to a robot. If you have a virtual robot running on your computer, because you can simulate a robot on your computer, so that's why you will be able to test things by yourself at home if you want to, if you don't have access to a robot. But in this case, we have robots, so IP 161. Yeah. We have to provide to the application our IP. So TCP. And the port, default port. It's not as comfortable as I thought. There you go. Of course, if we want to use the SDK, we have to import it. So, import Aldebaran key application. Okay, that's the first thing we want to do. We are going to create our application. Then we need a session to access the modules. Session, and we will ask our application for the session. Don't hesitate to ask questions as we go along. There you go. So, hello world. Basically, sometimes, usually you do that in the console mode, and we have robots that can talk. So, hello world will be using a text-to-speech module. Let's create a link to our module, text-to-speech. And we give it the handle to the session. A little bit different in this case. Every module is stored in a helper proxy folder. All right. It's a bit ugly, but just throw the exception. We are not here to deal with exceptions. There. So that's the first thing to do. Let's try that. Ah, yeah. This argument is right. Thank you. You're a bit stressing me. You're a big number of people. Oh, you're be kidding me. The robot lost the Wi-Fi? Yeah, the robot lost the Wi-Fi.
Hello, I'm Nico. My internet address is 192, 168, 248. My battery is now fully charged.
Good point. What would be my problem? Let's think about that. Robot URL session. Can you spot the difference? Sorry? All right. You see, that's why we need people from the outside. We are kind of diving into our robots. We spend all day with them, and we forgot the essential things that newcomers cannot miss. All right. Pepper would be maybe more cooperative. Woo. So, surprise, it was like a quiz session. Okay, I'm making mistake after mistake, and you have to spot them. It's not really a conference, it's like more training, okay? So when you come out, you will do everything but the little mistakes. Right? Cool. So be attentive. because I'm not going to miss you. I mean, to miss your mistakes. You know what I mean. Okay, so finally our hello world. And nothing else? No? It's the end of the quiz. And 2 dots. All right. And the IP address is wrong. Huh? Oh. You know what? I think I will just bring that a little bit closer again. Yeah, I can see a little bit more. Let's try again.
Hello world.
Finally! It's your work. It's all your work. Oh, it's on paper. Yeah. Thank you.
Hello world.
I think you can upload yourself, because it's all your code there. Awesome. Okay. At least the boilerplate code is there. We'll see a little bit more about other things. So Nicolas said that we have a lot of sensors on the robots. I will just make a short list of them. On paper, we would have on paper, we would have first tactile sensors on the head that you can find also on now. Little one.
Found it.
What? Okay. Stay calm. And would you mind looking at the front? We won't see your cameras there. No, it's fine, it's fine. I'm just teaching it to be nice. Okay, you're awake. Fine. So, sensor on the head.
It tickles.
Be nice, I said. Anyway, so tactile sensors on the head that we'll learn how to use just after that. You will have cameras in the mouth, in the front, on the forehead, sorry. You will have the tablet, of course, which is tactile, so you can use that as an input. You will have inertial sensors in the legs that allows paper to know in which position it is, if it's falling, but I never saw paper fall. Anyway, it's there. You have tactile sensors also on the hands. A bunch of infrared cameras there, in order to detect obstacles combined with lasers. Sonars in front, in the back. And finally, bumpers there, and there. And, of course, a 3D sensors in the eyes. That's the little red dot that you see shining in the right eye. So for the front row, maybe you see it. For behind, I don't know. In the cameras, I think you would see it if we zoom it a bit. Anyway, 3D sensor in the eye. The interest in these sensors is that with the API, you can grab the raw data and exploit it after. But with the functionalities that are provided with Naoki, you can use high-level functionalities. So with the 3D sensors, you can extract directly via functions that you have a certain number of people in front of paper. You can detect with the cameras, you can ask directly Naoki if the people are smiling, at which distance they are, and these kind of things. So if you want to exploit your own algorithms with the raw data, you can. But basically, you have a high-level API. So let's back to our code. We have an hello world, and we have sensors. let's try to use the head sensor. So in this case, the sensors are raising events that we are willing to catch and to react to. To subscribe to events, you need a module that is the memory of the robot. So let's import that first. Aldebaran, QA, helper, proxies, and memory. All right. Then we want a connection to this module. Memory mem, new, memory. Okay, we won't make the same mistake because we learn from our mistake, and we are not going to launch something right now and expect something to happen. Okay? We'll add some lines. Okay, let's subscribe to an event. Man, subscribe to event. And the event that we are willing to catch there is a touch on one end of the sensor. Let's take the front one. Basically, you have front, middle, and rear, and even if you cannot see it on the head of Pepper, it's there. You can better see it on the end of Nao, where you have 3 areas, front, middle, and rear. So here, front, tactile, sensor. And I can hear you mumbling, it's not an error that there is no E at tactile. We are just French people very bad at English. Anyway, to catch this event, we have another functionality, an object in our SDK that allows us to create a callback. So let's create that. And the value that comes back from the sensor is a float. So let's grab that and define what happens. It's screaming at me because it doesn't know about event callback. So let's teach him what it is. Helper. No. Oh my god. There you go. Okay. Override our method, public void on event. And we are catching, so a float. We're just going to throw away some exceptions that we don't want to deal right now. And code error. My god. Interrupted exception would be better. And Correro doesn't know about it. Import dot Aldebaran dot key dot. Yeah, I was sure about that. Okay, so we caught our event. What do we do with the value? If you touch the robot, the value would be 1.0. If you don't touch, 0.0. So if our value is equal to 1.0, then we would do something. And know that you will react because there is no point in doing it in console if we have a robot that can talk, right? So let's forget about system out. We'll use again our TTS to say something like, don't touch my head. Let's make that final so we can use it in our inner class. And we should be good to go.
Hello, world.
Okay, next with. No, really? You really thought it was going back on track with the conference? Yes? I'm expecting a lot from you. So, code review. You know peer review? We have a lot of peers. The application terminated, right? You're good. You're good. If we want our application to be to be there when we touch the event, we have to ask the application to keep running. App.run.
Hello, world.
You forgot something. You forgot something. I mistaken. It was to trick you.
Hello, world. Don't touch my head.
Applaud yourself. Okay. So that's how you deal with sensors. If you're interested in the list of events that you can handle, I'm just showing you a bit of our classic IDE, which is Choreograph, and in which you can, if you're connected to a robot, have access to all the events that are fired by the sensors and the other modules. So basically, our front, tactile, sensor, and touched are there. That's why I've been mistaken. Front tactile sensor does exist, but it's not this one. Okay. So, with Choreograph, the idea is that you also can control the execution of a virtual robot. That's what we were saying earlier, that once at home, you will be able to, after having learned that much during this quiz session, you will be able to not make any mistake at home using a virtual robot. The only thing to do would be to replace the robot URL by a local connection. Okay. What could we do more? Well, we started the session with a little bit of an exchange between the two robots. Maybe that would be interesting to know what kind of mistakes not to do with this kind of functionalities. So, as you see, there has been a little bit of lines to code, so we won't go writing it all. We are just going to see a little bit what happens there. Basically, if you want to control two robots in parallel, you just need one application because it will initialize the Naoki framework directly on your computer. You don't need to initialize it separately for two robots. The only thing that you need twice would be the session, one to connect to Nao, one to connect to Pepper. That's why you have one Nao session and one Pepper session. It's also the occasion to introduce you to some other modules like ALMotion that will allow you to give orders, displacement orders to the robot to control every joint one by one if you want to, or more globally. And one interesting thing over there would be animated speech. As you may have seen in the keynote, robots are not speaking, standing right there, looking blankly in front of them. It's allowed by this module, animated say. It will take whatever string that you feed it and generate random moves for the robot in order to have an animated speech, kind of speak by itself. Let's replace that. It did. just to show you this bit of functionality. Forget about that. And replace that. We'll no. Oh, yeah, Nicolas, thank you.
Okay, what do you think about this guy? He teaches you that much.
We have a little bit more move. Yeah, thank you. And this time I did it all by myself. Anyway, so let's back to the synchronization between robots. You have an application, a global application that allows you to access sessions. You have two sessions, one for one robot, another one for the other robot. The only thing you have to do is to create proxies to the different modules, and basically you're done. So, if we want to have a basic interaction between the robots, we'll remove everything from there. All of that we don't need. Wake up, save, and we'll forget about the rest. So we create a proxy on the now animated speech, one of the paper animated speech, and we can ask them to say something one at a time. Let's try that for now and for paper.
Hello, everybody. I am Now, and I am Pepper.
Okay, that's something. But it's basically one after the other, after the other, after the other, after the other. And generally, I like when conversations are dynamic, when people are interrupting each other and these kind of things. So if we want to have that with our two robots, we would need to make asynchronous calls. In this case, we can just add an async call. Not that much. Let's try that again.
And I am Pepper. Hello, everybody. I am Now.
So Wi-Fi reaction time different. But it's there. We have an asynchronous calls to the two modules. So we can imagine putting the right temporization. We can imagine to have a dynamic conversation between two robots interrupting each other and interacting with us. Interacting with us. Another functionality that we like to use in our robots is the speech recognition. Okay? If we want to use this kind of module, basically it's different imports. And we already have them over there. I'll remove them. Let's try something about that. Now, let's focus. Speech recognition. In this case, with speech recognition. Okay. Now and Pepper are using nuance technology for speech recognition, and their speech recognition is based on pattern matching. Okay, so if you want one robot to understand what you are saying, you have to give it patterns of the triggers that you want to use. If you want your robot to be able to respond to the order go to rest, you have to specify go to rest. How do we do that? Right. Speech recognition. Are you focused? There will be a lot of mistakes. Speech recognition. Provided the handle to the session. And we have to set the vocabulary that the robot will be able to understand. We specify that as an array list of string, words, you are a list of string. And we add go to rest. Speech recognition, we set the vocabulary. Words. No. Set. All right. Come on. Behave yourself. Enable word spotting. Yeah, why not? By doing that, you basically allow your robot to match patterns in the middle of a big sentence. So you don't have to just use the trigger. You could ask, Pepper, please go to rest, which is much more natural and which will allow you to have a robot that is capable of interacting with people that does not know your triggers. Okay. The next thing to do would be to subscribe to this module, because the voice recognition is not always active, so you have to trigger it. Subscribe, and you have to provide the name of your application, so let's define that. Private static. Okay. If we just launch that, well, let's do something else. If we don't unsubscribe at the end of the application, then your robot will be always listening, which is not something that we want. Okay, so we launched just that, and nothing much will happen, but this time it's normal.
Okay, what do you think about this guy? He teaches you good much.
Yeah, I should have changed that. So, vocal recognition is active. Go to rest. The green indicates that the robot is analyzing what it heard, but right now it's not doing that much. Remember about the events that are fired by the different modules. In this case, you have another event, which is word recognized, that we will be able to exploit. So let's look about that. We have memory imported, but we didn't have the memory initialized. Memory. Okay, mem.subscribe to event, and we want the word recognized. Create our callback, which will this time provide us with a list of string. Yeah. let's go. Override. Yeah, you know this part. Public void on event. And we handle our list of string. Interrupted exception. Code error. No. My God. Hmm? Sorry? Backspace. Oh, all right. Name of the parameter. What? Oh my God. Okay, so the robot will give you a list of words that it thinks it has recognized, followed by the confidence level. In this case, we are just interested by the first word that it has the most probably recognized. So recognized word, it's words.get 0. And if our recognized word is equals to go to rest, then we want the robot to be able to rest. Or just say, no, I don't want to. TTS, let's say, I don't want to. Yeah, you're right. And I'm so far from the screen. Sorry?
Le double W.
It's so different from an office, you know? Anyway. So in this case, say, what does it need? Does it need to say something? Of course. Let's first unsubscribe from that because we didn't unsubscribe before. Stop listening. Don't you want to stop listening? Pepper. If you don't do your best, it will be difficult. Go to rest. No. Okay. This one is my very big mistake, is that, as I said, you don't want your robot to be still listening at the end, so don't forget to unsubscribe, because in this case, I would not know how to deactivate the speech recognition without rebooting the robot. Anyway. There is still 13 minutes left. I would propose you to ask any question that you would have. I think you learned a lot. I learned a lot. That's the big thing. Anyway, so if we do just stop listening, thank you. Anyway. So, as I said, if you want to try by yourself, if you want to be largely better than what we saw today, you can download Choreograph, which will allow you to have a virtual robot running on your computer, and the Java SDK, which will give you access to the different modules of the robot. Some things won't work with the virtual robot, like for example the speech recognition because it's from the nuance technology, but everything about moving using the basic interaction that you can trick using the sensor. You can raise your own events to debug your application. So everything like that, you will be able to try it by yourself. And thank you for your kind attention.
Who's got questions? So we got one over here.
Yeah.
So how much does it cost? Those robots.
Those robots?
What is the price?
Nicolas, if you want to.
I was sure that I was going to be in charge of answering. So for now it's sold around 8,000, something like that, and it's sold worldwide. For Pepper, at the moment, I can give you an answer, but just about the Japanese price, because it's only available on the Japanese market at the moment, so I cannot guarantee that the day we have Pepper available in Europe, it's going to be the exact same price model. The idea is that you pay upfront first, and then you can register and have monthly fees in order to have additional services. So Pepper is about 2K at the moment upfront, but it's just like you got the robot, you go back home, and we don't want to hear about you. So in case it breaks or anything, then you charge full price in order to repair your robot. Then it can also come with a subscription that is about 100 euros a month, where we take care of the hardware for you during 36 months. And same thing, there's another plan where each month we give you new content for the robot that is about the same price. So in the end, you get a robot between 7 and 10K after 36 months. So that's really a price model that is at the moment just for Japan, and I'm not sure we're going to have the same thing in Europe or in the US the day we release it. But to give you an idea of the price, this is it at the moment. Any other question? Yeah.
So what's the commitment on the Now robot versus the Pepper robot, actually?
What's the future of Now?
Yeah.
Because we are coming with Pepper that is new, so the question is about the future for Now. Obviously, we don't address the same market. So there's no competition between Now and Pepper, since both of them are addressing different markets. I'm running a lot of workshops with kids with Now. I don't think that necessarily I can do the same workshop with Pepper, because kids would be more impressed by Pepper. So as an educational tool, I am not sure that Now is going to be replaced that soon, even though you could do exactly the same thing with Pepper. It's just that it's easier for kids to handle Now than it is to handle Pepper. Then for the business use cases, it really depends on what we plan to do. What I mean is that Pepper is more mobile than Now, but you cannot carry it in your arms. So for example, if you are at home, it's harder to take the robot by yourself and go upstairs than it is to carry Now, for example. So both robots, from our point of view, even if they run the same technology and so on, they don't answer the same problems. So I'm really not sure that Pepper is like a threat on Now, not at all. At the moment, it's really like understanding which market is more interested by which robot and making sure that we can provide the solution that comes with it. Other questions?
Another question?
Yeah. Why was it only released in Japan? So the question is, why was it only released in Japan? So Aldebaran was created 10 years ago, but we were bought by SoftBank, which is a telco operator, 3 years ago, and they wanted us to build a dedicated robot for them that they could use in shop. Hey, guess what? It's Pepper. But at first they wanted to keep it for themselves. They put the money on the table, and they wanted to make sure that they could take advantage of the robot in the first time. Another element is that Now is a small robot that you can ship pretty easily and so on. So for everything that is customer care related, that's easy. I mean, you can ship it. At the moment, the batteries that we have on Pepper don't allow you to put Pepper on a plane. So it means that it's released at the moment in Japan because they also know how to take care of the robot, and they have all the warehouse and factories where they can do that. It's kind of the same decision as what you would have as an answer from an automotive company. It's not just about selling the car, it's about making sure that we can take care of the car once you buy it. And that's the same reason why we are step by step opening the market in Europe, and we want to do that in the US, because it's not just about selling the robot, but making sure that we can take care of it for our customers. But it's coming. I think that in the year or 2 years to come, the paper should be available more widely than it is at the moment. So the question is, do we think people are ready for that? Ready for what?
To interact with robots in a supermarket or in banks? Or...
Do we think people are ready for that? Honestly, we can see that there's a big difference between Japan and the rest of the world. Clearly, that's all they've been waiting for at the moment. For Europe and for the US, you can have a doubt the fact that it will require some additional work, I guess, to make sure that people are comfortable interacting with the robot. But we can see that they got a lot of attention at the moment. So I'm not sure that saying that is answering your question. At the moment, we get a lot of interest, but that's the beginning. Will this interest be the same in 2 weeks, in 2 months from now, once people have seen at least once the robot? I'd like to think yes, but I cannot commit at the moment and make sure that it will be the case. But when they release it, or when we have people visiting us in our atelier in Paris, it's like a showroom that is open to the general public where they can come and see the robot. We definitely see a lot of interest, and people are. We can see that what they expect from the robot is really in advance to what we are. What we can release at the moment. What I mean is that the level of expectation they have is really higher than what we can do clearly at the moment with the robots. So I don't see no reason for them to feel like that there are some questions related to society. Will they take our jobs and stuff like that? Questions related to privacy and so on. But once they are in the same room as the robot, I don't see them being afraid or trying to stay away from it. On the contrary, they really want to interact with it and get close to the robot. So it will require necessarily some adaptation, the kind of applications that we are using in shops in Japan. Even us at Aldebaran, when we look at them, sometimes we're just like, what the fuck? So it's really, we know that the content needs to be culturally adapted to the audience that the robot will be interacting with. So the application made for Japan will be reworked so as to be released in Europe or in the US. But for the rest, yeah, I don't see people being like, let me far away from this robot. It's really, they want them. Not as bad as Japanese people want to, but they want them.
If I can add something on to that, for my part, I'm working at the atelier that Nicolas mentioned, which is a discovery space for general public to come and discover the robots, interact with them, discover what they are capable of. And basically, you see certain amount of people coming in and kind of being afraid of, as you said, losing jobs, perturbing the economy and something. And basically, when they arrive, they interact with the robots and they see by themselves their capabilities, their limits. They achieve this kind of realization that the robot can do much more than they thought in some way, but it's not threatening. And we observe that what you said, that people are not they are not putting any distance between them and the robot. If they do, it lasts for a few minutes, and once they see the robot greeting them, proposing to shake hands or these kind of things, they cannot resist the urge to come and touch the robot, interact with it, and they more clearly see the potential key usages that the robots can provide, which are not in contradiction with them keeping their work. If it answers a bit. Yeah.
Do they break often?
So the question is, do they break often? Yeah, it's exactly that. I mean, it depends on how you use them. Now, I'll take the example of Nao because that's the one we are the most used to. Nao can fall from his own height, and it's going to resist. It's not going to be broken that easily. On the other hand, there was a report like a month ago about a drunk man in Japan who assaulted a robot. And that kind of
the first assault on a paper.
Yeah, that's it. So for these cases, I mean, the robot has not been designed to be assaulted. So they don't break that often. it really depends on the usage. Basically, they've been designed to be pretty robust, but once again, it really depending on the usage. At some point, it's also mechanical devices, though. Just like your car, you also need to take care of them before they break. That's another important element to take into account, and things that we are working on our side in order to be able to detect default before they happen. But as they are, and for regular usage, no, these are pretty robust robots.
Can you do maintenance of the robot yourself, or you have to?
No, so the question was about maintaining the robot by yourself.
Can you repair it, or is it absolutely not?
No, in most cases, really a lot of developers are asking us if they can do that by themselves. But it's not that easy, to be honest. Most of the guys who try to pay attention to that or invest time in doing this usually wait for the warranty to be over before starting doing this kind of thing. So for us, it's really, we don't let people put their hands on the hardware because whatever you do on the hardware might have a lot of consequences on the rest of the robot. Changing some part inside the hardware will have an impact on the balance of the robot. So if he is to fall each time you launch an app because it's supposed to be balanced and is not because of small changes inside of the robot, then that's something that we don't want to necessarily face. That's the same reason why you cannot modify the hardware and why the real place where you can experience freedom with the robot is really on programming, but we don't let you change that much of the hardware. At the moment, the only people who manage to modify the hardware usually, that was the first example I have in head, was to have a 3D sensor on Nao, and they basically just printed a socket for the head, so they can put the 3D camera on top of it. But changing things inside of the robot, very few people have been digging into that. There's a guy, an Italian guy, who bought it and wanted a black robot. So he painted the robot and he sent it 3 times, I guess, to our office, and we had to just make sure that the robot would work again. So that was really expensive for us. And we're not that happy with this kind of situation usually. So the less you change the hardware, the better it is from our point of view. And it's even worse for paper. Other questions? Time's up, I see.
Time's up, yeah.
We'll be around, not with the robot, but I guess that with our face and accents, you can easily locate us. Feel free to come and discuss if you have questions that you want to handle on a one-to-one side and not necessarily in front of everybody. Thanks for being there. And
thanks for your attention.
Yeah, of course, you can take pictures.
Yeah, if you want to take pictures.
You want me to take it for you?
Yeah.
Oh. Thanks a lot.
Thank you. Thanks a lot.
So if you